Hi, I'm Justin Hodgkiss, founder and CEO of Advemto. Flow cytometry is the workhorse of single-cell analysis, and we've seen incredible leaps, with spectral unmixing now enabling 40-plex panels. But behind the headline is a painful workflow. We spend weeks or months on bespoke panel design and manual data processing. We often compromise on key markers because one small change would break a carefully optimized panel. We're fighting biological complexity with one hand tied behind our backs because the spectrum is saturated. At Advemto, we aren't just eking out more from the spectrum, we're adding an entirely new dimension: fluorescence lifetime. While today's spectral cytometers lack time resolution and lifetime cytometers lack spectral resolution, we've developed detection hardware that gives both at once. Adding lifetime drastically expands the optical space and relieves the heavy burden of spectral spillover. Take Alexafluor 546 and 555. They're nearly identical with a spectral similarity index of 0.981, but including their distinct nanosecond lifetime signatures reduces their similarity index by more than half. Building on our foundation in spectroscopy, we can now resolve the spectral lifetime signatures of cell-like beads. Our prototype resolves a nanosecond time series of spectra for each excitation color, and adding these channels beyond a purely spectral trace at the top creates a highly distinct signature for unmixing. For the user though, this is all in the background. Unmixing still uses single color stains, and there's no need to learn new file types or ways of processing and visualizing data. Previously, acquiring spectral lifetime data for a single particle would take probably minutes, a non-starter for flow cytometry. But our prototype can collect thousands of these signatures per second for individual beads or cells, and we look forward to sharing our latest at Cyto in Florida. Relaxing spectral constraints can standardize the practice of flow cytometry. If the panel complexity index is a proxy for your effort and pain, you're fighting an uphill battle above about 30-plex. Our instrument will push this wall out. So a 40-plex super panel would behave more like a manageable 20-plex panel. Or imagine being able to combine 3 or 4 pre-made 10-plex modules, plus your own drop-in markers in combinations that were previously incompatible. And downstream, clean data enables reliable automatic gating, giving scientists back their time and earning their trust. The most transformative impact of spectral lifetime labeling may be to bridge the separate worlds of flow and single-cell sequencing. Using combinatorial spectral lifetime tags, we create millions of unique optical signatures that are deterministically paired with the oligo barcodes for cell labeling. Our instrument measures a protein phenotype alongside this optical cell barcode, which pairs uniquely with the oligo barcode part read via single-cell sequencing. Crucially, this workflow directly maps the deep phenotype of a cell to its transcriptomic profile, which is impossible currently for spectral cytometry. Our team combines world-class photonics expertise with seasoned life science governance. Last year, we took a big step in commercial preparation through participating in the highly competitive BioTools Innovator Program. Our business strategy is a platform play, placing hardware to drive high-margin recurring revenue through our reagent kits. We're backed by a $2.9 million seed round and are executing our milestones at pace. We've filed 3 foundational patents in the last year, aligned with our business model, and we're preparing for our next capital raise to establish a US-based applications lab to drive our fee-for-service early access launch. Right now, we seek partners looking to apply this technology to their most challenging high-value applications, whether that's deep immunophenotyping or complex multi-omic discovery. We're Advemto. We're not just building a better cytometer, we're building the bridge to the next era of single-cell analysis.